Brass is an alloy of copper and zinc, in proportions which can be varied to achieve varying mechanical and electrical properties. It is a substitutional alloy. Atoms of the two constituents may replace each other within the same crystal structure. In contrast, bronze is an alloy of copper and tin. Both bronze and brass may include small proportions of a range of other elements including arsenic, lead, phosphorus, aluminium, manganese, and silicon. The distinction is largely historical. Modern practice in museums and archaeology increasingly avoids both terms for historical objects in favor of the all-embracing copper alloy. Brass is used for decoration for its bright gold-like appearance, for applications where low friction is required such as locks, gears, bearings, doorknobs, ammunition casings and valves, for plumbing and electrical applications, and extensively in brass musical instruments such as horns and bells where a combination of high workability, historically with hand tools, and durability is desired. It is also used in zippers. Brass is often used in situations in which it is important that sparks not be struck, such as in fittings and tools used near flammable or explosive materials. Brass has higher malleability than bronze or zinc. The relatively low melting point of brass, 900 to 940 degrees Celsius, 1650 to 1720 degrees Fahrenheit, depending on composition, and its flow characteristics make it a relatively easy material to cast. By varying the proportions of copper and zinc, the properties of the brass can be changed, allowing hard and soft brasses. The density of brass is 8.4 to 8.73 grams per cubic centimeter, 0.303 to 0.315 pound/cuin. Today, almost 90% of all brass alloys are recycled. Because brass is not ferromagnetic, it can be separated from ferrous scrap by passing the scrap near a powerful magnet. Brass scrap is collected and transported to the foundry where it is melted and recast into billets. Billets are heated and extruded into the desired form and size. The general softness of brass means that it can often be machined without the use of cutting fluid, though there are exceptions to this. Aluminium makes brass stronger and more corrosion resistant. Aluminium also causes a highly beneficial hard layer of aluminium oxide, Al2O3, to be formed on the surface that is thin, transparent and self-healing. Tin has a similar effect and finds its use especially in seawater applications, naval brasses. Combinations of iron, aluminium, silicon and manganese make brass wear and tear resistant. The high malleability and workability, relatively good resistance to corrosion, and traditionally attributed acoustic properties of brass, have made it the usual metal of choice for construction of musical instruments whose acoustic resonators consist of long, relatively narrow tubing, often folded or coiled for compactness. Silver and its alloys, and even gold, have been used for the same reasons, but brass is the most economical choice. Collectively known as brass instruments, these include the trombone, tuba, trumpet, cornet, baritone horn, euphonium, tenor horn, and French horn, and many other horns, many in variously sized families, such as the sax horns. Other wind instruments may be constructed of brass or other metals, and indeed most modern student model flutes and piccolos are made of some variety of brass, usually a copper-nickel alloy similar to nickel silver, germ and silver. Clarinets, especially low clarinets such as the contrabass and subcontrabass, are sometimes made of metal because of limited supplies of the dense, fine-grained tropical hardwoods traditionally preferred for smaller woodwinds. For the same reason, some low clarinets, bassoons and contrabassoons feature a hybrid construction, with long, straight sections of wood, and curved joints, neck, and/or bell of metal. The use of metal also avoids the risks of exposing wooden instruments to changes in temperature or humidity, which can cause sudden cracking. Even though the saxophones and sarrusophones are classified as woodwind instruments, they are normally made of brass for similar reasons, and because their wide, conical bores and thin-walled bodies are more easily and efficiently made by forming sheet metal than by machining wood. The bactericidal properties of brass have been observed for centuries, particularly in marine environments where it prevents biofouling. Depending upon the type and concentration of pathogens in the medium they are in, brass kills these microorganisms within a few minutes to hours of contact. A large number of independent studies confirm this antimicrobial effect, even against antibiotic-resistant bacteria such as MRSA and VRSA. The mechanisms of antimicrobial action by copper and its alloys, including brass, are a subject of intense and ongoing investigation.